In this video, I'm going to show you how to create dyadic structure from data that is not already structured for dyadic analyses. So in this data set I have, this is a data set I've used in my own research. I do not have permission to share this with anyone else, including for educational purposes, so I cannot include this data set in this video along with this video, but I will include the syntax for it. So I want to show you what this looks like when you have unstructured data. So in this data set, you can see I have, if I go down to the bottom, I have 23,864 participants. What I really have in here, let me grab my calculator real quick. So if we do 23,864 divided by 2, I have 11,932 matched couples. But this is not in any kind of dyadic structure. In fact, what this data set has is all of the variables, so everybody was asked the same questions for every single person. If you have a data set where it already has anchor partner, mothers, fathers, parent, child, that has the variables named differently, you can just move this into dyadic structure much more easily. Or if they're in two separate data sets, you can do that without doing it this way. The way I'm showing you today is for when you have a data set like this, where you have matched couples, they've all been asked the same questions, and you need to recreate this into dyadic structure with each person on the same line. So what I'm going to do then is I need to find out my index and my matching and my ID, so the matching variable. In this data set, match key is the matching variable that I can use to match my couples. So I've already ordered this. So you can see here that these first two participants have the same match key because this is a matched dyad. These are all matched dyads. There is a separate identifier, which is token, which I have over here, which is the unique ID of each participant. But this is my couple ID, this match key. In this data set here, one of the reasons I really wanted to use this as an example is because there's actually two different ways to create dyadic structure. And that depends on whether you're doing opposite sex couple research or mixed sex couple research. So there is one variable in here that identifies gender, so male and female. There's no transgender identification in this data set. So male and female, so we're going to use that to create matched same-sex couples. But if I want to include, matched opposite-sex couples. But if I want to include same-sex couples in my research, I then need to use a different variable. And in this data set, they labeled it kind of oddly. It's this @_I. This is my anchor partner data set. Where for this one, they have it labeled, let me go to it here. F means first and S means second. So F means they're the first person that responded to the survey, and S is the second. So I can use this to create an anchor partner data set where I have both opposite sex and same-sex couples in my data set. So I'm going to show you the syntax for how you do that. Let me drag this over here. So I start with making some notes to myself with what these variables are. So I have, to sort for opposite sex couples. So if I want opposite sex couples only, I use male, that's the variable name they had in this data set, where 0 equals female and 1 equals male. If I want to sort it by anchor partner for mixed sex couples, then I'm going to use this @_I, where F equals first and S equals second. And then I have the syntax listed here. So the first thing I have is my sort cases, just to make sure that it's sorted correctly, where it's sorted by match key and then male, which is my gender variable. My ID is match key, that's the matching couple ID. And then the index is what it's going to sort it by, would be males. So I'd have, again, 0 is females, 1 is males. And then this second syntax I have here is if I wanted to sort it for mixed sex couples research, where, again, same thing. I'm going to sort it by match key and then by my index, and then the index is the separating variable for the dyad. So I have my ID is match key and index is @_I, and then group by index. So first thing before I change this, I'm going to save it. I'm going to show you each of these. So let me save this one as, I'm going to save it as, there we go, structured opposite sex. Okay, so now I have saved it as, structured opposite sex. Now, there's one step I need to do before I'm ready to run this syntax. If I want to do opposite sex research here, there's going to be a problem. I have some same-sex couples in this data set. And SPSS is going to run into a problem because it's going to, the first time it gets to one of those same-sex couples, it's going to go, oh no, I don't know what to do because both people in this data set are the same for this variable. So before I do this, I would actually need to get rid of my opposite sex couples, otherwise I can't, or my same sex couples, otherwise I won't be able to do that. So in order to pull out my same sex couples, I need to filter these out. And now in this data set, I do have a variable named same sex. So this variable here, and I can click on my little description descriptors here, and I can see that in fact I have 626 matched, or 626 individuals that identify as that are same-sex couples. So and in that we can see 1 would be the same sex and 0 is opposite sex. So what I can do is then go to Data, select Cases, go find my same-sex variable, and then if this condition is satisfied. So if same-sex equals 1, I want to filter out unselected cases. So I'm going to hit OK, and let me make sure this is right. So let me go to same-sex, and we can see we've filtered out the opposite of what we needed to do. I did it backwards. This is why we do the filter out first. So let me go back to select cases, go back to my if, and have it be 0, and try this again. There we go. So now we can see that I have filtered out those that have the same-sex couples. Now what I can just do is then go to my select cases. Instead of filter out, I can just delete them. And I've already saved it as structured opposite sex, so I'm going to do this. So hit OK, and now I should have all of anyone who is same-sex couples out of this data set. So I can go ahead and run this syntax here that will allow me to create my dyadic structure. All right, so it has done this. You'll see in your output, it's kind of crazy long in your output. But if I go to my variables, go to my data view, I should now see that I have, instead of 24,000, I have around 11,000 couples. So let me go down to the bottom here, and in fact I have 11,619 participants, which this is couples. So this is dyadic structure. And if I go to my variable view, you can see it now has 0.0 next to all of the variables. This would be for women, and then 0.1 next to the men. So if you remember, M+ can't handle the point periods in a variable name. So if I wanted to rename these variables in a way that would work in M+, all I'd have to go do is go to my first, there we go, there's my first variables that I have there that have a 0.0, but I can just highlight all of these. I have a ton of variables here, there we go. There we go. Highlight all of these variables, copy them, open up Microsoft Word. Okay, so I now have it pasted into Microsoft Word, and if I hit Control-H, that'll pull up my find and replace, and I can take my 0.0, and that was, again, women, do an _W or an _F if you want to do females. Depending on how you want to do this. And if I can go back to my syntax and remind myself that 0 is females and 1 is males. So I can do that here and replace all of my .zeros with _Fs, hit find and replace, did all of them. And then I can do the same thing, 1 for dot underscore m for men. Replace all of those. Now those are all fixed, and I can highlight all of these thousands of variables that I have. Copy that. Not cut. Copy that. Go back to my data window. Let me go back up to the top. Make sure I have all of these highlighted. And then if I just hit Control V, or whatever your paste function is, wait a moment, it's got to think as it does all of this. It will rename them all. There we go. So now underscore M for man, and then underscore F for females. Because I've highlighted all, copied and pasted, they're all in the same order, it's all the same variables. So now I can save this, and this is my structured data set for opposite sex couples. Now the next one, I'm going to show you how to do this the other way when I'm doing mixed set couples. Okay, so I've opened back up my original unclean data set. So this is my unstructured data that I haven't done anything for. I'm going all the way back to that. I've reopened up my syntax window here. So I have here, sort cases by match key, and then, this at underscore I is my matching ID for who responded first and who responded second. Now, because I'm including all of my couples, both my opposite sex and my mixed sex couples in this data set, I don't need to do any filtering out of anybody. I can include the entire data set, so I am ready to just highlight these and run them. And again, match key, that is my couple ID variable, and then at underscore I is my anchor partner, so who responded first or responded second. Now I can go ahead and then highlight these and run it. And then I should see in my data view now, instead of about 23,000, I have 11,932. And if I go to my variable view, I can see .f. In this instance, F stands for first, and then .s stands for second. So I don't need to do any, well, I still need to do the same thing I did before because, again, the dot, it can't handle, M plus can't handle the dot. So if I do the same thing I did before, highlight this, go all the way down to the bottom, copy that, open up a new Word, new Microsoft Word, paste that in, hit my Control H, and replace dot F with underscore F. And in fact, I could even make this even quicker and just replace all my dots with underscores. So if I just did dot here and then replace with underscore, and then go ahead and replace all of those, you'll see it's automatically done that. And that's been a much quicker way to do that. So then I can just go through and highlight all of these, a couple thousand variables, copy, and then paste. It'll take a second as it does it, and then it'll be all set. There we go. So now, last thing to do is make sure I don't save over my original data set. So I'd save this as structured mixed sex couples. First, second. To remind myself, I organized it by first, second response. Save it, and then here is my data. So I have on here again, one couple is on a line, and I'll first have all the responses. Let me go up. All the responses from the people who responded first, so F means first in this instance, and then the same items that were asked by -s. So I can see here, let's take for example this item here, this Q151010, you'll see in here I have one for the first responses, and then again for the second responses. The same item for both people in the dyad. So now this data set is all set and ready to use for dyadic data analyses. So in this video, I showed you how to take a fully unstructured data set where you just have the same variable names for all your participants, but you do have matching couples in here, or matching dyads, and how to restructure that data into a dyadic data structure.